Hey, astronomy friends all around the world. I'm Roman Ride, Uranus spaceship quantum engineer and also the host of this program, and you're watching another episode of Uranus Spaceship Show. In today's show, did we find life on Mars or not? By now, you probably already know everything I'm about to say, but the video's here to explain every little detail about the Perseverance rover's discovery. It's a great discovery, but is it really life? Let's break it all down. Roll the intro. Alright everyone, new video here on the channel. Before we get started, go ahead and smash that like button, subscribe so you don't forget during the video, and help support science communication in the universe. This time, it's super relevant stuff that happened in our universe, actually what happened with NASA's Perseverance rover. So you guys can understand everything, here's the article that came out in Nature this week, reporting this discovery. But just a reminder for you all, this whole thing that happened was actually presented this week, but it's not new, okay? It's actually from last year. Last year, the Perseverance rover was exploring a region called Shiava Falls. These names are just given by the team for reference. So, it was exploring Shiava Falls. And there, it found a formation called Bright Angel, like you can see here, in July 2024. In that area, there's the Nerativa Vales. There's the Nerativa Vales, for those who don't know. You know, it's like this here. This is the Neratil Avalis, see? Then you've got the Shiava Falls, all that stuff here. And over here is the Bright Angel. See this little group of rocks right here? Yeah? This rock formation, this Neratil Avals, it's basically a valley that the river carved out to get inside the Jezero Crater, which is where NASA's Perseverance rover is. Pretty cool, right? Here's a picture of this amazing place, geologically speaking. You can see it's a bit different from that other area over there, but more sand dunes. And here he found this, which is actually the bottom of an old lake that used to be there on Mars. A lake, water, calm waters, really good for depositing organic material for life to settle. While studying there, they found this kind of outcrop. This is really cool because it's full of veins. The rover went there, used its equipment, drilled a little hole here, and collected the sample. That's how it collects samples. The one collected here. When it does that, you know, to do everything we're talking about, when the rover collects that sample, it studies it with Perseverance's equipment. Perseverance has two tools. One of them is called Sherlock. Sherlock is really important because it takes a spectrum in ultraviolet. When it does this kind of spectrum, it can give a clear idea of the presence of organic matter and other chemical properties of the rock you're studying. So he went there, used Sherlock, and also another device called Pixel, alright? He used Sherlock and Pixel, which does something like X-ray lithochemistry, X-ray spectrometry. This here is the Pixel, okay? So, let's check it out. He goes, uses the Pixel, see? The Pixel gets close to the rock and basically takes an X-ray of the rock. It's the same kind of X-ray they do here on Earth. The thing is, when he studies this, he also gets a kind of spectrum. Well, not exactly a spectrum, but something like that. Here's the image, right here. And this kind of image is really cool because it shows us the chemical elements. So, there are two of them. Got it? Now, what was interesting about this rock, it's these little features you see here that we call leopard spots. See that? You can see it clearly here. Why leopard spot? Because it looks like the spots on a leopard's skin. Over here there's some olivine or something, but what's really interesting is this part. Because of this type of geological feature that he found out, we, or the researchers, called this leopard spots, like leopard spots. Here it is, see? This is the rock he studied. It's pretty dusty, right? So here's a little picture of the Perseverance rover for you. Pretty cool. So, when he studied this, what did he discover? He went there, did all that, grabbed the rock, studied it with PIXL and Sherlock, like this here. And the first thing he did was this. Sherlock, which is the spectrograph, they did this kind of analysis. This here is the spectrum. When you do the spectrum, it already picked up the famous G band, the D band. Why is it important? It's around 1500, okay? It's roughly at 1500 and it indicates, listen up, the presence of organic compounds. Does that mean there's life? Number. Finding organic compounds doesn't mean you found life. There's a big step between one and the other, but it's already a strong hint. They grabbed the pixel from there, right? Then they checked out what kind of rock was there. Cool, organic material, great sign. Now let's see what we've got. The pixel does this kind of analysis here, see? It picks up the rock right there. See those spots? It scans them like that. What they found was this. They found the lamito, which is this mudstone, the main rock layer we call the matrizona. And there, they found these reaction front cores, the reaction ring around it. But reaction of what? Sure, some kind of chemical reaction happened in this rock, and that's where the big deal comes in, okay? This chemical reaction could be a biological process or a geological one. And this reaction created two minerals. One of them is really interesting, right here. Let me check the name for you. It created vivianite, which is also a very important mineral, but it also created this mineral here, called greigite, found in this ring. Greigite is a magnetic iron sulfide mineral, chemically similar to magnetite, which forms in sediments under conditions of microbial activity. That's the key point. So, if you look up greigite on Google, you'll see it's linked to microbial activity. What does that mean? It means that to form this kind of mineral, there has to be life activity involved. And that's what's grabbing everyone's attention. So, this mineral was found right there in the stain. Leopard, could it have only been created by life? Number, that's the thing. It could have also been formed by geological processes. So both biological and geological processes could have created that famous little thing. And that's where the second big part comes in. How are we going to find out? Probably never, okay? Probably never. To figure this out, we'd need to bring that rock from Mars back to Earth. Because here on Earth, people have all kinds of labs at their disposal. This rock is going to be studied, examined in every type of lab, and by doing that, we'll be able to understand all the processes the rock went through and figure out if they were biological or geological. If it's biological, awesome. We nailed it, there's life. If it's geological, then no life. And to do this, NASA has this really cool thing they call a code scale, or the 7 steps to confirm life. It starts here. We detect a possible signal, we detect it, and eliminate contamination. Apparently, yes. Now, let's move on like this. Make sure the biology is there to be sure that biology can actually produce that. We're sure that the gringito isn't just random, right? It's generated by a biological process. So we pass the first 3 steps. Now, let's move on to ruling out non-biological causes. We can't rule out the possibility that it's not biological. So, we're stuck. So, here's the thing, at step 4 of confirmation, we can't do the full analysis over on Mars. Even though Perseverance is an amazing rover, it can't do those analyses. So, what's the big deal? We have to bring the samples back from there. Are we going to bring them back? We don't know. NASA's Mars Sample Return mission was supposed to launch soon. Well, not exactly soon, more like around 2030, to retrieve the samples there. But right now, the sample return mission is cancelled. This actually caused some drama during the press conference, right? During the press briefing, the announcement about the discovery. You know? Everyone kept asking the current NASA administrator how we're supposed to go and collect samples if the mission's been cancelled. And China's coming in. China has the Tianwen-3 mission, that's what we call it, which is a mission to go and collect samples. That Chinese mission is expected to launch in 2028. So here's what's happening. Life, right? We don't really know, because if we go beyond this point, we still can't say for sure. So what do we have to do? We need to identify it, use independent signals and instruments to detect it, then rule out any other possibilities, and finally do an independent confirmation, meaning give the data to different scientists to see if they all come to the same conclusion. This is the process we call, folks, the code scale. That's what NASA talks about. We're stuck right here, see? Biology could possibly create greigite. We need to bring it here. To get it here, we just need a sample coming to Earth. Got it? So, just to leave a quick 15-minute summary for you about this super important discovery. Did we find life on Mars? Not yet, but we might have found what could be the best clue so far that life exists. Because yeah, there are plumes over there, but it's all really far away, you know? The plumes on Enceladus are far, and Europa is even farther. It's far away, but it's right next door, so this is the best way, you know, that we have to study and soon get confirmation if there's life, or if there was life on Mars, alright? That's the video I wanted to share with you all today. Hope you liked it. If you did, you know what to do. Smash that like button hard. It really helps the video and the channel get noticed. And don't forget the YouTube package. Share it around. Favourite, subscribe to the channel if you haven't yet. Drop in the comments whatever you want to know. We're all in this together, fighting against bad science communication in the universe and the lack of astronomy coverage in our country. Once again, I'm Roman Ride, and see you next time, Space Cowboy.